Assalamu alaikum dear students. Today we are going to start a physics chapter 8 long questions. Question is that define and explain enormous expansion of water. Enormous expansion of water. Liquid expands on heating except water. When the temperature increases from 0 degrees centigrade to 4 degrees centigrade, water shows an unusual expansion. How it shows unusual? And why it shows when water at 0 degree centigrade is heated, its volume decreases up to 4 degree centigrade, and from 4 degree centigrade its volume increases with the increase of temperature. This particular behavior of water is called the enormous expansion of water. Due to the formation of more number of hydrogen bonds, the water has enormous expansion. As the temperature increases from 0 degree centigrade to 4 degree centigrade, the density increases, and as the temperature further, the density decreases. Hence, temperature has maximum density at 0 degree centigrade. This why ice floats on water. Look at a diagram that it shows that on the surface of the water it becomes ice, and below the surface living life is going to be a continue. To see this part, ice cubes in water or the icebergs floats in ocean. Now the next question is, what are the applications and consequences of thermal expansion? You have looked at a book page number 214 also. The answer is that a thermal expansion is used our daily life. In thermometers, already we have seen the use of thermal expansion to measure temperature. Railway lines. When railway tracks are leads, the engineers leaves the small gap between two rails as shown in figure. If two railway tracks are led together without any gap between them, they will push against each other when they expand without the rise of temperature. This has caused them to bend as shown in figure B, or tracks may also break free from one another. Such a situation will result in a derailment of the train, causing major accident and loss of life. So the railway engineers also leaves the small gaps between the two rails to compensate for the expansion of the railway during the hot summer and the contraction during cold winter. Number second is open the lid, opening a tight jar lid. When the lid of the glass jar is too tight to open, holding the lid under the hot water for a short time will often make it easier to open the top expansion before the heat reaches the bottle, but when it not, metals generally expand more than glass for the same temperature change. Now the next is transmission lines. Transmission lines in the summer gauge more as compared to winter. Shrink fitting of axle into gear wheels. The axle have been shrunk by cooling in liquid nitrogen at 196 degrees centigrade until the gear wheels can be slipped onto them. On regaining normal temperature, the axle expand to give us a very tight fit. Now the next is a expand fitting iron ring on a cart wheel. As iron ring can be tightly fit on the wooden wheel of a tanga, at room temperature the diameter of the iron ring is slightly less than the diameter of the wooden wheel. The ring expands on heating and can be placed around the wooden wheel. When the ring comes at the room temperature, it contracts and produces a tight fit. Number F is the expansion joints. Most large bridge including expansion joints, which look rather like two metal combs facing on one another, their teeth interlocking when heat causes the bridge to expand during the sunlight hours of a hot day. The two sides of the expansion joints move towards one another. Then, as the bridge cools down after dark, they begin gradually to retract. Thus, the bridge has a built-in safety zone. Otherwise, it will have a room for expansion or contraction in response to temperature changes. Bimetallic strip. A bimetallic strip is used to convert a temperature change in a mechanical displacement. The strip consists of two strips of different metals which expand at different rates as they are heated. When their temperature increases, the unequal amount of expansion causes a bimetallic strip to bend, as shown in the figure. For example, if equal lengths of two different metals such as copper and iron are revolved together so that they cannot be moved separately, they form a bimetallic strip. When heated, copper expands more than iron and allows this strip bends with copper on the outside. If they expanded equally, the strip would have stayed straight. Bimetallic strip have many uses like fire alarm or thermostat. Now the next one is define the heat capacity and specific heat capacity of a substance. Expand the importance of high specific heat capacity of water. Heat capacity means thermal capacity. First we are going to define first heat capacity. The quantity of heat required to rise the temperature of a substance of mass m by 1 degree centigrade or 1 Kelvin is called the heat capacity, and it's represented by a cm of a substance. Mathematically, heat capacity can be given as cm delta q by delta T. The value of cm depends on the nature of the material of the substance, the mass of the materials of substance, the rise in temperature. In the standard international system, the unit of heat capacity in joules per Kelvin, which is expressed as joule per Kelvin. Cm equals delta Q by delta T. Delta Q units is joule and delta T unit is Kelvin. Heat capacity units comes as joule per Kelvin. Explanation of when a substance absorbs heat, its temperature rises. When a substance loses heat, its temperature decreases. Thermal responses of different materials of heat absorption is different. For example, water requires a lot of heat to exchange its temperature, while silver requires less heat to change its temperature. Specific heat capacity. Specific heat. The quantity of heat required to rise the temperature of unit mass 1 Kelvin of the substance by 1 centigrade or 1 Kelvin is called specific heat capacity. Mathematically, specific heat can be given as C equals to Cm by mass. Putting the value of C from equation 1 in equation 2. Clear? So we are going to put that C equals to a delta Q by mass delta T. The SI unit of specific heat capacity is joule per Kelvin, kilogram Kelvin. Explanation. Different substances have different specific heat. The quantity of heat needed also depended upon the nature of the material. Rising the temperature of 1 Kelvin of water is 1 Kelvin requires 4190 joules of heat, but only 910 joules is needed to rise the temperature of 1 Kelvin of aluminium by 1 Kelvin. Importance of high specific heat capacity of water. The specific heat capacity of water is equal to 4190 joule per kilogram Kelvin. It has some important implications. Moderate climate of sea shore. The specific heat of sand is about 800 joule per kilogram Kelvin. A certain mass of water needs 5 times more heat than some mass of sand. Hence, the land gets heated much more easily than water. Also, it cools down much easily. Hence, a large difference in temperature is formed that given rise to land breeze and sea breeze. It keeps the climate of the coastal areas moderate. Monsoon in Pakistan is also due to the difference in temperature between the land and the surrounding sea. As a coolant, water is used as effective coolant. By allowing water, it flows in a radiators, pipes of the vehicles. Heat energy from such parts is removed. Thus, water extracts much heat without much rise in temperature. It becomes steam at 100 degrees centigrade, and the same is true for the reverse. Next is what is meant by the latent heat of fusion and latent heat of evaporization of a substance. Latent heat of a substance. The heat required to change the physical state of a substance, solid into a liquid, or vapors, or liquid into a vapors, but does not change its temperature, is called the latent heat of substance. Latent heat of fusion, the amount of heat energy required to convert a given mass of a substance from solid states to the liquid state without any rise in temperature, is called its latent heat of fusion. Liquid release the same amount of heat when they solidify, means freeze. Specific latent heat of fusion, the amount of heat energy required to convert a unit mass 1 kilogram of solids into a melting point of liquid, or liquid in a solid without any change in the temperature, is called the specific latent heat of fusion of solid. Mathematically, if delta Q is the amount of heat energy is needed to melt mass m of a solid to liquid, or freeze liquid to solid, then delta Q equals to mF. When F is the latent heat of fusion of a substance, and it's given as LF equals delta Q by delta M. By rearranging the equation, the SI unit of specific latent heat of fusion is joule per kilogram. Latent heat of vaporization, the amount of heat energy is required to convert a given mass of the substance from liquid to the gaseous state, boiling without any rise in temperature, is called the latent heat of vaporization. Gases release the same amount of heat when they liquefy. And this question is going to be a complete. We will discuss inshallah in the next lecture of further question. Allah Hafiz.